Find the intervals of increase and decrease of y is equal to x minus cos 2x in the interval negative pi to pi. All right, so if we want to find the areas of increase and decrease, then we want to do the first derivative test. So let's find the derivative of this. So that would be y prime is equal to, derivative of x is just 1 minus, and then derivative of cos is negative sine. So we have negative sine 2x, and then don't forget multiply by the derivative of the inside, which would be 2. Okay, cleaning this up, we get 1 plus 2 sine 2x. Now if I just rearrange for sine 2x, we get sine 2x is equal to negative 1 over 2. All right, so now they've given us the interval for x, right? When I'm trying to figure out like where this is, it'll be helpful just to consider this for a second, like thinking about this as sine just theta is equal to negative 1 over 2, right? And then just solve for theta for a minute. Like that'll be a nice way to do it. So if this is our interval, like negative pi to pi, then if I change this to, let's say, 2x, right? Then what this has to be negative 2 pi to 2 pi. Okay, so that's kind of the interval I'm going to be looking on when I'm deciding where is this the case, right? Okay, so where is this the case? So you guys do have a formula, or a unit circle, and we can see that sine is negative a half here and here. So that's going to be at 7 pi over 6 and 11 pi over 6, okay? So even if you want to leave it like theta for a minute, we can say, okay, theta would be 7 pi over 6 and 11 pi over 6. Oh, but, so if we think of what we've just done now, right, we found this one, right? That was 7 pi over 6. And we also found 11 pi over 6. And that would be on our way to 2 pi, right? But we need to account for the other direction. So if we were going the other direction, then we consider this as just being pi over 6. So we also have like negative pi over 6 to keep to bring into account. So like negative pi over 6. And then we also have negative 5 pi over 6. All right, so now I'm just going to write those out one more time just in order, just from least to greatest. So that was negative 5 pi over 6 to negative pi over 6 to 7 pi over 6 to 11 pi over 6. All right, so those are the numbers where this is true, right? But that's what's true for theta. Remember, we, for a second, just called 2x theta. So let's actually just rewrite this now. 2x is equal to, actually, just so I don't take too much room, I'm going to do this. 2x, so I don't have to write it all again, is equal to all of this. And you can see what can happen. Like if I now divide everything by 2, then we get x is equal to, so then the 2 is just being multiplied in the denominator by all these. So I get 5 pi over 6 times 2, so 12. And then negative pi over 12, and they just all become 12. Okay, so then 7 pi over 12, 11 pi over 12. All right, so now let's sketch our line with our numbers on it. So this will be negative pi, and I'll have pi over here, right? That's our interval. And then if I just, this doesn't have to be accurate, but just to get my bearings here, I'm just going to put 0 right in the middle. Negative pi over 12, so to the left of this is just past it. So maybe I'll make a different color there. So maybe somewhere in here, you know, negative pi over 12. Okay, and then, you know, this isn't very, not the scale. Okay, so negative 5 pi over 12, something like that. And then on the other side, right, then we're actually closer to pi on the other side going around. So this would be, you know, over here, maybe 7 pi over 12, and then, you know, close to the end here. We're at 11 pi over 12. All right, so we're interested in what's happening in the sections in between, right? And let's think about, too, just so we can get some like numbers on these, because you get kind of lost sometimes. So if we're thinking of numbers to use for like our test values to figure out whether we're positive or negative, our first one was, well, let's see what happens between negative pi and negative 5 pi over 12. Okay, so where is negative 5 pi over 12? So negative 6 pi over 12 would be right here, right? Negative 6 pi over, oh, that was weird, over 12, because that's negative pi over 2. So that would be right there. So I must be like, just to the left of that. So I'm somewhere in here. So this first interval, I'm checking in here. Okay. So yeah, we can, an easy one to check would probably be, straight down. Let's check at negative pi over 2. So for that one, if we used our equation, so when we took our derivative, we were here, right? So we want to see what this comes out to. So 1 plus, just for reference, so y prime is 1 plus 2 sine 2x. So if we throw in negative pi over 2 in for x here, let's actually just do it. I'll kind of show you. So if we would get negative 1 plus 2 sine, and this would be 2 times negative pi over 2. So 2's cancel. So we really have like sine of negative pi. So that's 0, right? So your sine value is going to be 0. So this is 1 plus 0. This thing's coming out positive. All right, so what that's telling us, we know that we are increasing in this region. And just to remind ourselves why, we'll say f prime of x is positive here. Okay, so now the next one gets kind of a little bit tricky in this place, right? So if we think about where this is, okay, so we've got negative 5 pi over 12, and then negative pi over 12 is negative pi over 12 is just past, right? Like 1/12 of the way around. So we're really in between here, right? So let's actually just try a number. Let's actually just maybe 11 pi over 6. So if we do that, and probably at this point, we just throw in your calculator too, like 1 plus 2 times sine 2, and then it would be negative. Oh, yeah, not 11 pi over 6. You'd want negative pi over 6. It'd be the same thing, but yeah, negative pi over 6. And we'll see how that comes out. Okay, so if we do that, we get 1 plus 2 sine of 2 times negative pi over 6. And we get a negative number. Okay. So that's all we really needed to know. So that means that we are decreasing in this region, because f of x, or f prime of x, is negative. Okay, the next region should be a little bit easier because 0 is in that region. Let's actually just use 0. So I can say, if I threw 0 in there, 2 times 0 is 0, so sine of 0 is 0. And then 1 plus 0, it's positive. All right, so then in this region, f prime of x is positive. All right, so then the last one would be, well, 7 pi over 12 would be just past, right? Because 6 pi over 12 is just pi over 2. And then 11 pi over 12 is over here. So we're good to test any one of these. So let's try, I don't know, 3 pi over 4. Okay, so if we went y prime is equal to 1 plus 2 sine of 2 times 3 pi over 4. Well, we actually probably do this one in our heads even too, right? But because you can go 2 over 4, which would be the same thing as 3 pi over 2, right? So sine of 3 pi over 2 would be negative 1 times 2 would be negative 2. 1 plus negative 2 is negative 1. So it comes out negative. But if you want to, you can always plug it in too. So we could say 1 plus 2 sine 2 times 3 pi divided by 4. And we in fact get negative 1, right? So we get a negative out of that. Whoop. Okay, so negative means that we have that we're decreasing there. So f prime of x is negative in that region. Okay, and then we just still have this last little region here up until pi, right? All right, so now in this one, we just need to get like really close to pi without actually getting to pi, right? So if we're already almost there, 11 pi over 12, why don't we try out, I don't know, even 12 pi over 13, right? That's even closer, right? That should do it. Okay, so let's do the same thing, but we'll just try out now 12 pi over 13. All right, so we got 1 plus 2 sine 2 times 12 pi divided by 13. All right, and all that matters, it's a positive number. So we're increasing here. So now let's formally write out our intervals. So we'll say that we are increasing from. Now, do we use a square bracket or an open bracket? Well, that's really going to depend on whether or not it was equal to or not equal to in the original, right? So since it's, x is greater than or equal to negative pi, we're going to use a square bracket. So it's going to be square bracket, negative pi, comma. It's going from negative pi to negative 5 pi over 12. And since negative 5 pi over 12 would actually be the peak, well, I'm not going to say that's increasing, so it's not going to be including that number. So round bracket, and then unioned with, and then we're going to go from, well, where is it increasing again? So then it starts increasing again from negative pi over 12. So negative pi over 12 until 7 pi over 12. Okay, not including either of those. And then it increases again on that last section there. So unioned with, and then from 11 pi over 12 up until pi. And it would be a square bracket because it included it. All right, now let's see where we're decreasing. So we're decreasing on the interval. So it's in this region. And it's not including, so negative 5 pi over 12 up until negative pi over 12. Unioned with 7 pi over 12 to 11 pi over 12. And then round bracket.